Hello and welcome to the Faculty of Engineering and Design's virtual tour. This unit will cover the lab spaces used for the Department of Mechanical and Aerospace Engineering, which includes aerospace, biomedical and mechanical, and sustainable and renewable energy engineering. This tour was developed by students and researchers of Carleton University in collaboration with the Faculty of Engineering and Design and the Carleton Immersive Media Studio, or SIMS team. During our tour, we will walk through campus, enter labs, discuss the equipment, and hear from current students about their experience. Each of our destinations will be marked with a red sphere and have been captured within a 360-degree photosphere, which enables you to pan around the three-dimensional space. During our transitions from room to room, I encourage you to ask any questions you have about engineering and design at Carleton. Now let's get started. Our first stop is the Academic Support Office, found on the main floor of the Minto Center for Advanced Studies in Engineering. Probably been receiving a lot of emails from our Engineering Academic Support Office, or the ASO for short. The ASO team is here to assist engineering students with course selection, registration, learning resources, and extra support. They are available to help you from your first year all the way through to graduation. All ASO services are currently being delivered remotely, but the team is always just an email away. Erin, could you tell us about your experience with the Academic Support Office?
The Academic Support Office was there to help me create a schedule that worked for my needs and really made sure I felt ready for my first year in engineering.
The Elsie McGill Learning Center, EMLC, is focused on furthering students' understanding and comprehension in their engineering studies and provides students with the academic support they need to achieve their learning goals. The EMLC operates using a peer tutoring model to offer academic support to first-year engineering students. Peer tutors, who we call scholars, are hired and trained to assist you in your learning. Whether you have a quick question, want to review a solution, or just need a fresh explanation of content that was covered in class, our engineering scholars are here to help with your first-year engineering courses. And while the EMLC can't be delivering in-person services this fall, they will be available through a new online tutoring platform. Imran, can you tell us about your experience with the Elsie McGill Learning Center?
Yeah, for sure. I used the Elsie McGill Learning Center a couple times through my undergraduate degree, especially in my first year. The Elsie McGill Learning Center was extremely helpful in helping me review topics before midterms and final exams to make sure I had all my bases covered, as well as just to make sure I had a more thorough understanding of all the course material.
We are now going to head to Mackenzie Building. Although both buildings are connected, it's nice to walk outside through the engineering quad where there's picnic tables, benches, and summer study spots. In the winter, students often opt to keep warm by using our heated underground tunnel system that can connect you to any building on campus. Now let's head inside. This is where complex manufacturing takes place for all 13 of the Department of Mechanical and Aerospace Engineering capstone projects. Students have access to the shop throughout their 3rd and 4th year courses. This space contains computer numerical controlled lathes and milling machines, or CNCs. Also a number of drill presses, manual mills and lathes, a welding station, and a state-of-the-art 5-axis 3D metal printer. CNC machines process pieces of solid material like wood, metal, or plastic to meet specifications provided by a coded program output through various types of software. Manual machines produce similar objects as CNC machines, however, these machines are manipulated without the use of a coded program. Therefore, the machinist analyzes the engineering drawing and operates the lathe or mill to produce the part. One of the most important aspects of getting to a finished product is to correctly communicate your ideas. Early in the design stage, students can and are encouraged to sit down with the machinist to discuss their ideas and learn about and understand manufacturing processes. This interaction between students and the machinist is a stepping stone to proper communication through professionally produced drawings that industry will be looking for. Now let's hear from Imran about his experience in the machine shop.
With my involvement in Ravens Racing, we've used the machine shop several times, both to have parts for the vehicle manufactured, as well as to weld the entire frame of the vehicle. Machine shop is an extremely useful resource that's used very frequently when it comes to building parts that are set out to be made by 4th year students, or emergency parts when things go wrong.
Both 2nd and 3rd year students use this lab to understand the fundamentals of thermodynamics and heat transfer by analyzing gasoline engines, diesel engines, gas calorimetry, and carrier air conditioning systems. These engine tests are done to determine power, emissions, and engine efficiency. This mini cooling tower experiment is used to understand how superheated water with debris is transformed to clean cold water. This lab is set up very similarly to the solid mechanics lab. 2 teachers' assistants will assist groups of 2 to 4 students complete the lab within the 3-hour period. Imran, can you tell us your favorite experiment in this lab?
My favorite experiment performed in this lab was the engine test lab. In this lab, we used data on specific fuel consumption for each engine over a given time period and analyzed how much horsepower each engine put out. We were able to find the efficiency of the engine and make some conclusions about the engines themselves.
Third and 4th year students use this lab to understand aspects of aerodynamics using fluid dynamics. This channel is used to study high angle of attack flows dominated by flow separation and for rotary wing wake analysis. Using a dyed water channel for these tests allows for accurate testing of small-scale models while producing excellent flow visualization, which helps researchers understand airflow behavior. Imran, how did you use this lab?
In one of my fluid mechanics courses, we used a separate water channel in the same laboratory to do an analysis for a phenomenon known as hydraulic jump. This is truly one of my favorite labs that we did in my undergraduate degree.
Both 2nd and 3rd year students in the Department of Mechanical and Aerospace Engineering will use this lab to understand the fundamentals of solid mechanics. And using the blue rigs seen, students are able to analyze the deflection and strain in different cross-sectional area beams by adding weight to one end of the beam. Then, using this experimental data, students will apply the theory they've learned in class in order to determine the minimum and maximum stresses, elongation, and yield strength. These labs are typically done with 2 teachers' assistants, with students in groups of 2 to 4, and the lab report must be submitted at the end of the 3-hour lab period. This requires students to practice time management and preparation. Also, it is important to note that our laboratory technologists are always available to help with curriculum, lab assignments, and 4th-year projects. Imran, what was your experience like in the solid mechanics lab?
The solid mechanics lab gave me a real insight on the material properties. It's one thing to learn in class about how a material will deform under certain conditions, but it's totally different and extremely valuable to see that with your own eyes.
This is the Carleton University Simulator Project. It was introduced in the 2002-2003 academic year with the aim of exposing students to the latest in-flight simulator technology. And using a Gout-Stewart platform and powered mecanum wheels, the flight simulator can rotate with all 6 degrees of freedom, meaning it has no limitation to its motion. The cockpit sits inside a 9-foot diameter sphere composed of 4 composite panels reinforced by an internal structure of ribs. You will also notice an array of different dots around the exterior of the sphere. These are used as a tracking system in order to determine where the pilot is located inside the simulator during a simulation. Students will have the opportunity to work on this 4th-year project under the supervision of professors and laboratory technologists.
We're now headed to the 3rd floor in the Mackenzie building. You're currently in the office space for the Carleton Student Engineering Society, or CSES for short. All students are members of CSES and have access to many of their services like textbook trades, networking nights, social events, and much more. Dency, who is currently the VP of Finance, is going to be talking a little bit more about what the CSES office does.
CSES offers academic events and social events to all of the Carleton engineering community, such as the Carleton Engineering Competition and Trivia Nights. They also offer conferences where engineering students can go meet students from other universities. CSES also offers funding for clubs and societies and for 4th-year projects.
The 3300 block is unique to the engineering building. This block is dedicated to our engineering clubs and societies. There's stream-specific societies like CMAS and SRESOC, and engineering clubs like EWB, CU in Space, and many more. This area is also home to Leo's Lounge, which is completely volunteer-run. It's also the cheapest spot on campus to grab a coffee or snack before class, or if you're just looking to hang out, play some games, and make new friends. Nancy's going to talk a little bit about her time involved in the Carleton engineering community.
I've been part of CMAS and Q for the past few years. Q is a Carleton University Enterprise where I was finance director. At CMAS, I started off as a first-year rep and then made my way up to be a finance director. I was also a cast member in Michael Mia. Sound familiar? That's because the Carleton Engineering Musical puts on 2 parody shows every year. I was also part of EngFrosh, which is the fall orientation program geared towards the engineering and design students. I started off as a Frosh, then a Facil, and now I've been planning member for 2 years. I would highly recommend students to get involved in the CEng community. It helps you make meaningful connections and develop skills that you don't learn in class.
This lab introduces all first-year engineering students to electrical circuits and mechatronics. Students are introduced to DC and AC circuit behavior and electrical measurements using waveform generators, oscilloscopes, and multimeters. Students are introduced to digital systems based on the Raspberry Pi single-board computer. Python coding is used to enable sensor measurements as well as control of displays and actuators through the general-purpose input-output GPIO pins. Students work in multidisciplinary groups to complete a mechatronics project. Now let's hear from Erin about her experience in this lab.
The Mechatronics lab was my first real hands-on engineering experience. Before then, I had never touched a breadboard, let alone a Raspberry Pi, and being able to use them both with my new coding knowledge to design my own project was absolutely amazing. It can really confirm for me that I wanted to be in engineering.
This fall, lab stations will be remotely accessed from outside the university. Students are able to control the generator and oscilloscope or remotely program the Raspberry Pi and observe the results through a webcam. TAs will be available in the lab and by phone or Zoom to help students through their experiments. We are now going to leave Mackenzie Building and head to our last stop for the tour, located in Canal Building. On your left, you'll see the University Center, which houses the bookstore, cafeteria, pubs and restaurants, student associations, lecture halls, and classrooms. Staying outside, the quad has picnic tables and benches to enjoy lunch or study in the summer. Okay, let's head into our last lab.
This lab is used by 3rd and 4th year biomedical and mechanical engineering students. It is equipped with an MTS servo hydraulics load frame, OptiTrack system, joule press, porcine bones, and biomedical tools. such as hip plants, screws, and rods. 8 students will work in groups of 4 with 1 teaching assistant to test the effectiveness of biomedical implants. Students will have the opportunity to clean porcine bones, test them under load and tension, break the bones, implant the biomedical devices, and test them again.
We have now reached the end of our tour. Thank you for joining us today. If you have any questions, please feel free to ask them now or email us at engineeringoutreach@carleton.ca. Best of luck, and I hope to see you around.